Okay, let's try this again. Human Spaceflight Podcast, Take 12. Hello, and welcome to my podcast on the evolution of spaceflight. Spaceflight is an amazingly wonderful and expansive world that humans are just starting to discover and explore. I hope that after listening to this podcast, you as well will agree with me on this fact. So, just sit back and take a listen. We start our journey with early spaceflight. The first crafts to go to space were all unmanned and remotely operated. In fact, the first craft to reach the Kármán line, which is a universally agreed upon boundary of space, was a ballistic missile created by Nazi designer Wernher von Braun. It was called the V-2 and was a result of their quest to increase the range of ballistic missiles for use in war. Other types of unmanned craft are test crafts. An example of this is the Little Joe rocket series created by NASA. The Little Joe was made to test various systems, usually abort systems, on the Mercury capsule before it was sent up with an astronaut on it. The Little Joe 2 was created to test abort systems on the Apollo capsule. Finally, the last type of early unmanned craft were satellites. They were satellites that were put into orbit around Earth. The first ever man-made object in orbit was the Sputnik 1. It was launched by the Soviet Union, and it started the space race, which eventually ended with Neil Armstrong on the moon. There were also many different human spaceflight programs that were made, the first of which was the Soyuz program. This was created by the Soviet Union and carried the first person into space, Yuri Gagarin. This was a wake-up call to America, as they hadn't made any advancements yet, but their arch-rival had already put both the first human and man-made object into space. America raced to catch up with the Soviets. They created the Mercury program. It only held one astronaut, but it carried the first American into space, Alan Shepard. Another astronaut that was taken into space using the Mercury capsule was John Glenn. He was supposed to do 11 orbits, but his heat shield got loose. To keep it in place, they didn't jettison the retro package and brought him down early to prevent it from falling out of place in the orbits. After this, he only did 3 of the planned 11. After the success of the Mercury program, NASA, or the National Aeronautics and Space Administration, decided that it wanted more. As a successor to the Mercury program, they created the Gemini program. It sat 2 people, hence the name Gemini, which means 2, and took the astronauts into orbit around the Earth, even setting an orbital altitude record. The astronauts in the Gemini capsules would even go out for a spacewalk if they so choose to. This was the first time that they could do that safely and without life-threatening exhaustion. The Gemini program was such a success that they even considered something called the Advanced Gemini program. The idea is that they would upgrade the Gemini capsule and put it on a stronger rocket. This would allow the capsule to be used for missions to the moon. This was, of course, before the creation of the Apollo program. Another upgrade that was considered for the Gemini capsule was the Big Gemini program. It was basically just a regular Gemini capsule, but with increased storage space. It was basically an early space shuttle. This, just like Advanced Gemini, never left the drawing board. After the Gemini program was the Apollo program. This seated 3 people. It was made to do the moon missions that NASA needed to end this space race. The first Apollo mission never left the pad as the entire rocket went up in flames. All 3 of the astronauts tragically died in the cockpit. So, NASA decided to completely tear down the rocket to find out what was wrong. They found and fixed the problem. The next Apollo missions were just scouting for the big one. Apollo 11 was the first to reach the moon. NASA kept sending up missions to the moon, but Apollo 17 was the last one due to budget cuts. In fact, the Apollo 18 rocket and moonlander had already been built when the budget cuts happened and they had to stop the Apollo program. The rocket and lander now reside in the Kennedy Space Center exhibit down in Florida. It takes a lot of power to get all the way to the moon. This brings us to the topic of propulsion. There would traditionally be 2 different types of engines on the rocket. The first one, usually on the first or booster stages, would have a smaller bell that was optimized for operation in atmospheres. The second one, usually on the upper stages, would have a larger bell that was optimized for operation in the vacuum of space. To prevent against failures, most rockets were armed with an abort control tower. This was a tower on the top of the capsule that would wrench it away from a failing rocket if need be. Some of these could pull as much as 15 Gs of acceleration. That sounds like it would hurt a whole lot. One of the capsules didn't even have an abort tower, and that was the Gemini capsule. They, in fact, had ejector seats. This is, of course, completely preposterous, because 1, they couldn't eject in space, and 2, the fire from the engines in the seats would ignite the pure oxygen gas in the capsule, inflaming the astronauts inside of the Gemini capsule, like the later Apollo mission. The way that the towers would know when to abort was using wire detection. There would be wires running down the sides of the rocket. If one of the wires was broken, it would trigger the abort control tower. This mostly always works, because if the rocket is exploding, it's practically imminent that one of the wires would break. This brings us to the topic of modern spaceflight. Most spacecraft are currently unmanned. However, SpaceX, a company by Elon Musk, is trying to build a capsule called the Dragon capsule. The Dragon capsule seats 3 and would be suitable for sustaining life in orbit. It is currently making unmanned supply trips to the ISS, and is, in fact, the first private capsule to ever connect to the ISS. So, it's pretty cool. And the Dragon capsule doesn't have an abort control tower like most other capsules. Instead, it uses an inline abort system. The abort thrusters are built into the side of the capsule. Many modern capsules that are being developed by private space companies use this type of abort system. On the Dragon capsule, there are thrusters on the sides of the capsule. Meanwhile, in the capsule being created by Boeing, there is a giant solid-fueled thrust engine in the center of the capsule. If you remember the Soyuz program by Soviet Russia that took up the first astronaut, you'll be surprised to know that this program is actually still in use by Russia. In fact, NASA is paying Russia to send up astronauts with the cosmonauts in the Soyuz capsule to the International Space Station, as the shuttle program was canceled. It must be very uncomfortable for the astronauts in the capsule. It is super squished in there, and the ride lasts for 6 hours. NASA is currently working on the Orion capsule. It'll seat 4 people, and it will be used on the space launch system that NASA is currently working on. Well, they say that they're working on it, but they have already poured about $8 billion into the SLS, and they have just finished the design and started work. As I said before, the space launch system is a rocket that NASA is working on. The idea is that they would be able to customize the rocket depending on the mission. It is the rocket that NASA is going to use to go to Mars and beyond. This rocket will carry the Orion capsule. Sadly, NASA doesn't know exactly when it will be finished, as they just started work on it. Most of the rockets that are in use as of now are all unmanned, except for the Soyuz craft. The aerospace company Rocket Labs is creating the Electron rocket. It's a lightweight orbital-class spacecraft that will deliver satellites. One of the cool things about it is that its engine is 3D printed using metal 3D printing. It is a low-cost option for businesses that need a satellite in orbit but don't have the money for a larger rocket. SpaceX made the Falcon 9. It is currently the cheapest rocket for its power. It is currently launching satellites into orbit around Earth. It can launch multiple satellites in a single launch, which can make it cost-effective for things like radio stations or cell services. It also has a device in it which can allow it to move to different orbits to place different satellites in different orbits. The Falcon 9 is the first fully reusable rocket in history. All that SpaceX needs to do to reuse an expended rocket is to switch the payload and refuel it. Once SpaceX finishes the Dragon capsule, it'll take astronauts to orbit. It is taking the Dragon capsule to the ISS on unmanned resupply missions. SpaceX has also decided to make a more heavy-duty version of the Falcon 9 rocket for use on heavy-duty payloads. It's basically just 3 Falcon 9s strapped to each other. It has flown a couple of times, and is just as reusable as the Falcon 9, but costs more and can do way more. However, this isn't nearly enough for the mission to Mars that SpaceX is planning. So, to do this, They are making the Starship. It is a giant rocket that will be suitable for the Mars trip. Actually, the Starship was originally called the BFR, which stood for Big Frickin' Rocket. But now that they've decided to actually make this thing, they needed a name change. The idea is that it will launch on a giant booster stage. Then, the Starship will separate from said booster stage and, well, just go to Mars. It can seat up to 7 people. The landing method that it uses is less than traditional. It will fall belly first into the atmosphere, quickly dropping speed. Then, once the speed is low enough and it's close enough to the ground, it'll get vertical and do a slave burn to land via its thrusters. Not only are we putting astronauts in rockets, we are also putting them in orbital stations. The only orbital station as of now is the ISS. It stands for International Space Station and is a giant, amazing feat of engineering. It was assembled piece by piece in space. Not only is it a symbol of what humans are able to accomplish now, but it is a symbol of global diplomacy. A whole bunch of countries work together to make the ISS, and they all use it together. At any time, there are over 200 experiments going on up there. It has lasted for many years, and will continue to last for many more, but they are talking about retiring it. Instead, they are going to build the Gateway Station. It is a lot smaller than the ISS, but it will orbit the moon. Most of the time, it'll be empty, due to the immense cost that it would be to get there. It would be assembled piece by piece, just like the ISS, but it'll take a lot less time due to the fact that it's a lot smaller. On the Gateway Stations, the astronauts will have a very crazy ride, as at the Parapswis, it will be so close to the surface that it will look like they are going to crash, and at the Apoapsis, it will look like they are drifting away. Not only have rockets gotten a lot better with time, but so have propulsion. There are many different types of fuels now. Liquid fuels. They are sorted into 2 categories, monopropellant and bipropellant. Monopropellants only have one chemical and are ignited to create thrust, just like any fuel. Bipropellants have 2 different chemicals that are used. The first chemical that is used is called the oxidizer. This is literally just liquid oxygen. Often, you will need more oxidizer than you need fuel. This is the second chemical. There are many different fuels that are used. They range from RP1, which is a more refined jet fuel, to liquid hydrogen or even liquid methane. Bipropellants are even further divided down into 2 categories, hypergolic and non-hypergolic. Hypergolic fuels ignite upon contact, while non-hypergolic fuels are the vice versa. They need an external source to ignite. The abort system used by the Dragon capsule uses hypergolic fuels, but most rockets use non-hypergolics for propellants. Non-hypergolic fuels can provide more thrust, and hypergolics are often carcinogens, meaning they can cause cancer. Every rocket in use right now uses either solid fuel or liquid fuel, but there are some alternatives. Many satellites use ion drive propulsion. It works by making lots of electrons shoot out very fast, and that causes thrust. They're really fuel efficient because they run on electricity and neon gas. Xenon gas doesn't take a lot to transport, and the electricity can be made from solar panels. Sadly, they do not provide nearly enough thrust for rockets and will remain that way for many years to come. Like the ion drive is the plasma thruster. It uses various gases and turns them into plasma, then propels them fast out of the thruster. Like the ion drive, it produces little thrust. However, the gases that it needs are not nearly as easy to transport as xenon gas and electricity. Also, with plasma engines, there is a high risk of the rocket just randomly going boom due to the plethora of instabilities caused by turning gases into plasma. Finally, the amount of energy needed to actually carry out this process is way too immense to be a feasible option for any satellite. The reason why rocket bells need to change sizes based on external pressure is that the flow of hot gases needs to remain as straight as possible. In an atmosphere, we can make it straight because of the external pressure pushing on the flow. However, in the vacuum of space, there is no external pressure. This causes the gases to just dissipate outwards. There is no way to fully counteract this, so we just put as big of a bell nozzle on the engine as possible. This is where aerospikes come in. They point the thrust into a slope that will counteract this effect in the vacuum of space. It works just as efficiently in the atmosphere as well. On the topic of efficiency, aerospikes are even more efficient than an optimized engine in most cases. They may seem like a dream, but they heat up really fast, and there is a high risk of them just melting themselves. There are two types of aerospikes, the linear aerospike and the toroidal aerospike. The only difference is that the toroidal aerospike is a circle, while the linear aerospike is a line. Toroidal aerospikes are used by some jet planes. However, linear aerospikes aren't used at all. In the future, rockets may not be the only thing to go to space. Some companies are working on space planes. They're orbital-class spacecraft that are planes instead of rockets. Space planes would be awesome, but sadly there aren't any as of now. These planes are often SSTOs. That stands for single stage to orbit. SSTOs don't change stage during the trip to orbit, and therefore carry all of their mass with them from takeoff to orbit. They, just like spaceplanes, haven't been really created yet, but there are oodles of designs for them. Because they can't switch engines, they must use one that is efficient in both atmosphere and vacuum. For this reason, the designs often use aerospikes. In the past, NASA experimented with nuclear propulsion. It was basically a mini nuclear reactor being used as a rocket thruster. It sort of worked, but it had a very low thrust output, it was very efficient, and, most of all, it was dangerous. Thanks for listening to my podcast on the evolution of spaceflight. Now, you can see why I am so amazed and captivated by this wonderful world of engineering. Anyway, my time is up. Again, this has been Leland Kilburn, and thanks for listening. Goodbye.